Thank you very much, Philip, for that generous introduction. And I will speak for just one moment on both of our behalves and thank all of you for coming this evening. Thank NYU Abu Dhabi for this invitation and for a very warm welcome. We have enjoyed our short stay and look forward to continued conversations with those of you here in Abu Dhabi. Just a word about the format for this evening. Tyler will give us a presentation for about half an hour, and I'll offer just a few very brief comments at the end, and then we will open it up for conversation with the audience. We're very interested in having as much dialogue as we can in the time that we have together this evening. So with that, I'll ask Tyler Volk to share what he's brought with him tonight.
Okay, thanks. And I second all the expressions of gratitude that Anne had just now. So I'm very pleased to be here, and my brief presentation really has two parts. The first part is to give you some background on the carbon cycle and to really try to get it across that this is something to celebrate, the wonderful super metabolism that we all live within of carbon going in and out of different forms, and that we as organic beings actually participate in. And then in the second half, I'm going to move into the concerns about the carbon cycle, which have to do with the rising levels of the concentration of carbon dioxide, the very important greenhouse gas, which is increasing from the combustion of fossil fuels, and look at some of the ties between carbon dioxide, energy consumption, and economic well-being that then we are going to address in a bit of conversation and open it up to a further dialogue with all of you, which we much look forward to. And I'm going to have Anne click me ahead, and so I can stand up here and point out certain things. Yes, the right-hand side. So the book CO2 Rising, I did bring a few copies, just a few copies in the luggage from New York, and if any of you would like to look at the book or purchase it from the Institute, it's up at the front at the reception desk, and you could do it on the way out. So CO2 Rising, and I'll tell you why it's the world's greatest environmental challenge as I go along. A bit of background: carbon dioxide molecules, one carbon atom surrounded by two oxygen atoms. The geometry is very important because it's the fact that this atom can bend as sort of hinge and makes it a greenhouse gas. The bending of the molecule corresponds to the kinds of energies that the molecule can absorb, and the kind of energy this molecule absorbs and re-radiates is the infrared, which I'm going to go into next. So I'm going to give you just a few slides of what the greenhouse effect is, because I find people are often a little fuzzy about it. It's something to do with energy and heat in the atmosphere. I'm just going to give you a little bit of technical background about the greenhouse effect. Infrared radiation cannot be seen with our eyes, but humans can build cameras, and so you can take a picture of a house in, let's say, around New York City in wintertime and see where the heat is coming out of the house to try to analyze the best place to put insulation, for example. Snakes, pit vipers, rattlesnakes have special sensors to sense infrared so they can see the mice at night. We just have not evolved the senses to see infrared, but we can see it with our instruments. Infrared is important because this is the energy by which the Earth cools itself off to space. The Earth is a radiating body in the infrared. This is important because carbon dioxide and other greenhouse gases, unlike the two atom molecules of oxygen and nitrogen in the atmosphere, the most abundant molecules, unlike the most abundant molecules, the greenhouse gases can be very minute in amount, but yet be very important because they absorb this infrared radiation that the Earth is emitting. So what the greenhouse gases do, and here you can see the carbon dioxide, it absorbs, it blocks the infrared, and it re-radiates it, and since the molecules, unfortunately, don't know up from down, they re-radiate it in both directions, and some of that new infrared goes back down and warms up the surface. So this is all happening invisibly to our eyes, but the physicists know about it, the climate modelers. This has been very well studied. There's no controversy here at all. In fact, this the infrared absorption of carbon dioxide is how the scientists measure the concentration of carbon dioxide in a sample of air by putting infrared in, and how much gets absorbed, how much does not go to the other side, tells them the concentration. This is very well established fact. So with that little background on the greenhouse effect, it's time to do some celebrating of cycles, the circle dances that carbon does in the atmosphere. And now I introduce a carbon atom, D. And D, in the book, I decided to name a carbon atom, and the MIT Press editor, when he first saw this, I was giving a carbon atom a name, Dave, thought, this is not really a book for MIT Press. But after he read a few chapters, he told me that, whoa, it's really a way, following the carbon cycle from a carbon atom's point of view is a good way to get into some material that could otherwise be quite complicated. I didn't arbitrarily choose the name Dave. It's named after, in a way, honor of Charles David Keeling. He used to be known as Dave Keeling, the scientist who discovered the increasing amounts, discovered the fact that the CO2 was increasing in Earth's atmosphere. Now, D can be in a carbon dioxide molecule or a bicarbonate molecule. The other atoms around here are oxygen and hydrogen. Or Dave can be in a cellulose molecule, one of the most important molecules on Earth, because it allows trees to grow up tall and stand. It's a structural molecule. And you can see that this carbon atom can be in different molecular forms. And this is a very important fact about these carbon cycles. It's not carbon dioxide we're talking about. It's the carbon itself that can go in and out of different forms, one of which on the far right is carbon dioxide. Now this carbon dioxide molecule, Dave, can go into plants through little holes in the plant's leaves called stomates, or stomata, and it can go through several molecular transformations. It's no longer as carbon dioxide once it's in the plant. It gets put into sugars, proteins, lipids. In the case of barley, which you may eat, it goes into starch in the grain, and you eat the starch, and it's in a molecule that's similar to that cellulose molecule, a large molecule, and you digest it. And then when you digest it, you gain energy from it. It's really similar to the way a car driving is going to gain energy from gasoline, another carbon-containing molecule. The oxygen gets combined, creates carbon dioxide, it goes off. And you know what? We also give off carbon dioxide from our breaths as we digest these molecules. And so there I am giving off 5 times 10 to the 20th molecules of CO2 with every single breath. That's a mind-boggling number of carbon dioxide molecules, and you can see why molecules and atoms are only a few hundred years old in terms of humans really knowing about them, because the scale is so small. And I figured out what happens to the molecules of this breath that go out into the air, and some of them are going to go into leaves. The leaves are going to take the carbon dioxide through those little holes I just showed you and transform it into molecules of their bodies. The carbon is going to go into different molecules in the leaf, some cellulose, starches, proteins in the leaf. And I did the calculation, and I had this checked by a number of other carbon cycle people because it really astounded me when I did it myself. And it turns out that from my exhalation, carbon from my exhalation ends up in every leaf in that picture. And not only that, it ends up in every leaf growing on Earth over about the next year. Every exhalation that I give off, and not only which exhalation, every exhalation I give off has carbon dioxide molecules in it, and some of those carbon dioxide molecules go into every single leaf of the planet. About 50 atoms of carbon in every leaf that grows everywhere is coming from every single one of my exhalations in the previous year. And not just me, and all of you. So we all get embodied in all the vegetation of the planet during the next year. So that's some of the magic of the carbon cycle. Now, Dave, the carbon atom, actually emerged from a crystal of calcium carbonate 30,000 years ago in the book and got washed out of a limestone cliff just as about the time the first cave art was appearing in Europe. So this is just the dawn of what might be called, well, it's really the Paleolithic time, Upper Paleolithic. Now, during those 30,000 years, Dave traveled around, was in the ocean about 100 times, went into land plants a couple hundred times. Is this possible that a carbon atom that emerges from rock stays around and starts circulating in and out of these different forms in our surface systems for 30,000 years? Indeed, yes. In fact, Dave will have about another 70,000 years on average here. The same thing's going to happen to our fossil fuel carbon atoms, incidentally. And one of the things that happened to Dave was in the early 1960s, Dave was in a parcel of air traveling across the mountains of Hawaii and went through a tube in this meteorological station and got analyzed as part of the world's first online real-time analysis of atmospheric carbon dioxide by Dave Keeling, who was running this laboratory for the US government at that time. And we see the results of what happened. It was the discovery of the carbon dioxide rising in the atmosphere from about 320 parts per million to now about 385 parts per million. It's a very small amount, but in the way that you can put a little food coloring into water, just a tiny drop and it colors the water, carbon dioxide doesn't color the atmosphere, but it affects the atmosphere by absorbing these infrared radiation. And so even though it's a very small amount, it can be, not only can it be a very potent effect, if we were to remove the carbon dioxide from today's atmosphere, the Earth would enter, be a permanent ball of ice. So we have to celebrate its warming the Earth to a level we want, but this became, right to the scientists anyway, really in the early years of great concern because they realized the fossil fuel CO2 that we're putting up into the air is not just disappearing into the ocean. Some of it is staying in the atmosphere, and this is going up and up every single year. You know, there's talk about the economic downturn last year, and maybe the world's gross world product went down 3%. Well, that means 97% of the world's economic activity kept on going. 97% of the previous year's CO2 kept on getting put into the atmosphere. The CO2 is still going up. There's natural CO2 that enters. Dave entered from the dissolution of limestone. CO2 comes out of volcanoes. And so you might wonder, how does the natural fluxes compare to the human CO2 fluxes? Well, what are the human CO2 fluxes? The breath is one flux, but that's not the cause of the greenhouse effect at all, because from our breaths, the CO2 came from animals and plants or mushrooms, and that came ultimately from the atmosphere as CO2. So when we digest food, we're just part of a closed, a perfect circle. However, we take coal and we dig it up, and this is carbon from deep underground. It was once ancient forest. It was once land, plant carbon. We dig it up, burn it, make CO2 and put it into the air. That's one form of us, not the volcanoes. We're kind of a human volcano bringing this carbon up. And this also happens with natural gas. The next slide. That's methane, natural gas. 1 carbon, 4 hydrogens. You burn it, you get water and CO2. There's another of the big 3 of fossil fuels. Oil is kind of similar to coal, but it comes from marine deposits. I'm not going to show you that separately. But these are all carbon-containing molecules. And then, so we can, the data is quite well known. This is in billions of tons of carbon released as CO2 each year, starting in 1850, the dawn of the Industrial Revolution, and now around 2006, we are now peaking more than 8 billion tons a year, more than a ton of carbon per person globally, average, put into the atmosphere as fossil fuel CO2. You see, first it was a lot of coal, oil came on strong, and gas is coming on strong. How does that compare to the nature's volcanoes? I put a red line down here for all natural carbon entering the surface system from deep below. The volcanoes emit CO2, the rocks, the carbonate rocks dissolve, and it's about 0.4 billion tons. Humans surpass that before 1900. Humans surpassed all of nature's input. So there's natural input, but humans are 20 times above that. And that is obviously overloading the system. And that's increasing. Now I need you to click this several times because I want to show you that the atmosphere is connected to the plants in the soil, the ocean, and they're connected through rivers to each other. And so the atmosphere is not just a closed bottle that the CO2 goes up into. The carbon starts circulating in and out of these different forms, which makes the carbon cycle really fascinating to know about, even in a kind of a simple way, the way you may go to your doctor and you have you know something about your heart and lungs. Finding out something about the atmosphere, the soil, the ocean, I think is sort of interesting for every Earth citizen, especially since this is not going to go away. This is with us the rest of our lives. We're living in this carbon age of increasing CO2. It's going to be in the news. In the last 10 years, it's now being talked about, almost daily in the newspapers. You put it all together. We understand the system of fluxes here, and we are injecting some right into the atmosphere. These fluxes are very large. What goes in and out of the ocean each year is much larger than what we put in. But the fact that we keep overloading the atmosphere means that some of it's going back into the system, but not all of it, as you see. But we would want to make sure, could nature get out of balance? Could some of the changes be due to these natural fluxes getting out of balance since they're so large? The answer to that comes from the ice cores, because scientists found out this really amazing fact that you can go to Antarctica, dig down into the ice, pull up ice that's 1,000 years old, was formed 1,000 years ago, and there's tiny little air bubbles in that ice. You can take it back to a laboratory, crush the ice in a vacuum, extract the air bubbles, and measure the atmosphere from 1,000 years ago. And so we have the results. And here is today on the right. Here's the high CO2 level, about 385. Go back in time around 1850, and before that, it was level for that 1,000 years. I mean, little fluctuations, but these data points, it's basically level, which means the systems of nature were virtually perfectly in balance. These circles are working as circles to take and return the same amounts. And we now know, I'm not going to show you, we now know that the CO2 has never been as high as it is today, has never been that high for at least 500,000 years, 500,000 years of direct measurements. And we have proxy measurements that go back even farther than that. So we really are putting the Earth into a new state, and this is as good a demonstration as any that it's really humans since about 1850 with the Industrial Revolution creating this increased CO2 in the atmosphere. We can have pretty good predictions of the future of CO2 because with the next slide, you can do a model, very simple models, and lay the model on top of the data, and it's about 43% of what we put in is remaining in the atmosphere each year. And this amount has been remarkably constant. It varies from year to year, but on the average, it's this 43%. So if we know the carbon science is down pretty well, this is good news. So if we know the amounts we're putting in, we can fairly well predict the concentrations in the atmosphere going into the future. And now I want to get into briefly what that future is. There's going to be very difficult geopolitical decisions to be made for the following reason. Around 1957, Dave Keeling also established a CO2 monitoring at the South Pole. The idea being, let's see what it's like at the South Pole air, very far away from the industrial emissions in the Northern Hemisphere, as far away as possible from the Northern Hemisphere. So what happens? Normally when you have a pollutant, it's less as you go farther away from it. Let's see how much less that happens with CO2. I'm going to show you a little animation here and talk about it. I've put the Hawaii data in gray here. So I faded it out into gray. That's the data that comes from the Northern Hemisphere. The black is going to be laid on top of it. That's the data from the South Pole air. there's some missing years here, but now 10-year chunks. Look at that. Right now it's tracking what happens. It's tracking what's going to happen to it. It's tracking the Hawaii data. It's tracking the Hawaii data. This is very, very important. This is a profound understanding that's come out of studying the carbon cycle. The fact that the air of the South Pole has the same increasing amount of CO2 as the air in the Northern Hemisphere. And the geopolitical implications of this are the following. Countries that have done almost nothing to cause the greenhouse effect are going to get not just a little greenhouse effect, they're getting the same greenhouse effect. The CO2 is mixed, the air circulates it, and it's the same everywhere. So the whole world is getting the same increased amount of CO2 year by year, no matter what particular countries did for emitting or not emitting. This is really a huge issue that's going to, why things like Copenhagen, is driving people crazy. What's going to come out of these talks because of this fact? It's not a local pollutant. Okay, places like Rwanda, where a friend of mine was working in villages there, took this picture of selling sticks. They're selling sticks for fuel. And they're going to use sticks to cook pots of rice for school children because they don't know how, in the schools, they don't know how well the children are going to eat when they get home at night. And they're using sticks. Now, sticks are potentially part of these cycles as long as you're not deforesting, which is an issue we can get into. But they're using biological materials because they're poor. And this is in Bangladesh. They've collected the rice straw. They've collected some of the parts of plants. They're saving it. And you're going to see now a woman putting the rice straw in to cook her rice. They're poor, and these countries are going to want to develop, and they have every right to develop. And Rwanda doesn't have many people, but Bangladesh has 100 million people who are going to want to increase their standard of living. In our world today, that means fossil fuel. And Dave the carbon atom was in this rice grain and came out after she digested the food. So these cycles are continuing. Okay, the world's gross product has been increasing, and it looks here on this graph remarkably quickly. This is the gross domestic product, but taken over the world, the summed over the world. And if you put this on a log plot, and which I did here, the gross world product is headed for about 250 trillion US dollars in the year 2050. And the number is not so much important as the following fact. It's been growing remarkably steady for about 3% per year for the last 30 years. There's sort of a global economic machinery going on. The year 2050 is interesting because at that point, if the world is 8 or 9 billion people, everybody on the planet would be living at approximately the level of today's Europe or Japan. Now that, in one sense, seems shocking because the world is going to increase its economic activity 4 times everything currently being done today. And yet, this is very desirable. And I wish it could be done faster to bring everybody up to a decent standard of living. And that's not saying everybody's equal. That's just the world average. So I am not trying to deal with inequity. But that's a kind of an interesting thing to think about because today, the U.S. GDP per person, energy per person, and CO2 per person emissions is between those 3 factors are between 4 and 5 times the world's average person, which I've just set equal to 1 to do relative comparisons. Set those equal to 1, and the U.S. is 4 to 5 times. Now, you sort of know, the U.S. is relatively wealthy, use a lot of energy, the energy is fossil fuel, but how close those are. It's a system. Wealth is energy, and energy today is mostly fossil fuel. Those things probably are moving up and down. I'm going to show you some other areas of the world. What's happening in India, what's happening in China, Africa, and Europe. And I'll give you a little bit of the UAE also. Europe and Japan, a little bit more efficient than the United States. It generates wealth more efficiently with CO2. but still there's a system going on in which they are well above the world average in all those three parameters. China, look at China, GDP per capita, energy per capita, and CO2 emissions per capita, just about the world average. To image the average state of the planet right now, the economic average state of the planet, image China. China is in Mexico, Romania, Turkey. These countries are the average state of the planet. You look at India, well below the world average, over 1 billion people. Africa, 800 million people, very, very poor. This tells a lot in the story. They're poor, they use little energy, and they have very few carbon dioxide emissions. And presumably all those are going to come up in the future. The UAE per capita relative to the world average. This is relative to the world average. The GDP, about 3.3 times the world average, very close to Europe. The UAE is very close to the EU, just a little, but still in the same system of developed countries. The CO2 emissions per capita of the UAE is about 7 times the world average. Notice that the US is 4 and the EU is 2. So this is kind of interesting because the EU might serve as a model in a way because they are generating wealth with far fewer, almost only 1/3 of the CO2 emissions as the UAE, and which is even higher than the US. I haven't gone into looked at the reasons why, but clearly neither the UAE or the US can be models as systems for the future because they could be models for sort of economic aspirations that we're going to talk about, but they can't be models for CO2 emissions because we're the whole world. To live like the UAE, the annual emissions would be 7 times what they are. And there's no climatologist that says that would be anything but total disaster. The United States might be model for economic aspiration, but cannot be a model for CO2 emissions because the CO2 emissions would be 4 times what they are today, and that would be clearly a climate disaster. And so I'm actually going to skip this. It has to do with relative amounts of energy and CO2 over time. We can project these fairly well into the near-term future for economic development. And what we get is a CO2 projection in which by the year 2050, the carbon dioxide in the atmosphere is up about 100 parts per million more. It goes up about the same amount that it rose between 1850 and 2005. The first 150 years is going to rise in the next 150 years, that same amount. This is taking into account what they call business as usual, which is already incorporating significant energy efficiencies because it's projecting what has been happening in terms of energy efficiency already. So it's not just projecting today's world. There's with the economic development, there's already energy efficiency which may not be that easy to have. So already it's kind of a desirable projection from what it could be. It could be even higher than that. We may want to try to keep it level. We may want to try to bring it down, but then oil crisis is going to come in at some point too, and new energy systems are going to be ahead of us. So I think I'm just going to go quickly over the next two. I want to get to the picture. We can talk about scenarios. I'm not going to do that right now. Different scenarios we can do that in conversation. One more, and this is 70,000 years in the future. Dave the carbon atom got into the shell of a coccolithophorid, a marine plankton that is a calcium carbonate shell. And that coccolithophorid fell through the ocean water, did not get dissolved. It fell into certain areas that did not get dissolved. It got into the sediments, got buried, and taken out of the system. Dave the carbon atom emerged into our surface circulating circle dances of carbon 30,000 years ago, stays around for another 70,000 years and goes out. The same is with our CO2, our carbon atoms that we brought in from fossil fuel. They're actually going to be here for about 100,000 years. They're not all going to stay in the atmosphere, but that's something to contemplate, that we are, in a sense, affecting the chemistry of the planet for the next 100,000 years. most of our viewpoint is something closer. You know, we're looking 50 years, 100 years, and I gave you a little bit of sense of the issues that are going to be coming into play over the next few decades with regard to CO2. So I did this as sort of to set a background for some conversation between Anne and myself and between you all and the two of us, and we could talk about any of these things, and I'll be interested to see what was most on your mind in the coming minutes. So I'm going to just leave this up, and Anne, I'm going to turn it over to you.
Great. Okay. Well, thank you, Tyler. Among the many questions that, as Tyler says, we hope we can develop through conversation with all of you is, of course, this question that the book raises around the connections between poverty and wealth being integral to contemporary levels of CO2 that we observe, and the question of moving forward, right? How, if historical development models were based on the burning of fossil fuels, can new models for socioeconomic development and energy efficiency not only emerge in short periods of time and be adopted in short periods of time, but be adopted at large scales, right? Mm-hmm. And Tyler and I have been conversing back and forth about the relationship between individual acts of energy efficiency practice and conservation versus the opportunities and challenges that we face at large scales. I'm talking about the scale of infrastructure, the scale of urban development, the scale, large scale thinking about how we not only foster innovation, but bring those innovations in terms of energy efficiency into practice as immediately and completely as we can. So this question of the present and future, emphasis on future, turns into how energy efficient can we be as we generate future wealth, but also where can we be most efficient? Where are the opportunities? And it turns out that many of those opportunities exist precisely in those places where the bars are quite low and where we expect to see quite rapid and are seeing quite rapid socioeconomic development and transformation. So not only what do the innovative energy systems look like moving forward into the future, but where will they be adopted and where are the opportunities for that adaptation or adoption? Who will transform, as you write about so eloquently in the book, what you call the global industrial growth automaton, right? Global industrial growth models, which historically, right, have, as you say, burned fossil fuels in order to create wealth. And this puts a very different kind of a spotlight on the global south, a part of the world where I spend most of my time doing environmental research and working with people who aspire, as you say, to similar wealth levels of material comfort and aspiration, but whose means of achieving those aspirations are going to have to transform significantly. Did you have anything, Tyler, that you wanted to say before?
As Megan's going, so you and I at NYU, we see a lot of students, and we are in the environmental studies program, and the students are very concerned, and so they want to reuse their plastic bags or they recycle, and we talk about how these are small steps, but don't really address these larger issues, right?
Right. So which is not to downplay, right, the importance of our individual acts, the importance of individual awareness, and those projects are at individual and smaller cultural scales really important. But these kinds of global scale problems that you're outlining for us in the book require, it seems, right, a global scale way of diagnosing the problem, and from that diagnosis coming up with solutions that are appropriate, that are system scale appropriate, right? Which puts a lot of power and a lot of importance into the hands of the global south, right? Which up to not too long ago, the global south was, at least the global north was treating it as a place that could learn from our effective industrialization and development models. It turns out that we've now become students, right, of the global south and its own innovative practices and aspirations in terms of energy.
And let's be upfront that we flew here to talk about
absolutely.
CO2, and so we can't advocate the world's going to have to contract in some kind of way or adjust to a lower standard of living. You and I, talking extensively over the last couple days, have agreed that the goal is to get the world up to high standards of comfort, and yet we don't really have models for that yet.
Which is oftentimes news to a lot of American environmentalists whose ideas about environmental change often involve a scenario in which everyone's consumption patterns contract, which is, as I say, at certain scales, I think, a productive conversation to have. There is such a thing as environmentally destructive consumption, right? But when we think about global scale inequalities, poverty and wealth asymmetries, and trying to rectify those, or at least recognize the rights of everyone in the world to achieve similar amounts of development, then the conversation becomes one that's very different. It's one about greening and making more efficient the energy systems on which we all depend and through which wealth is generated, right?
And these countries they know this. Recently, Hillary Clinton was told by somebody fairly high up in India, and that doesn't represent all of India's official position, but this person said to Hillary Clinton, well, we'll talk about sort of reining in our CO2 emissions when we reach your per capita gross domestic product.
Right.
And that's going to be the attitude, I think, of China as well.
Right.
And I think rightly so.
Right.
I think rightly so. And I think you're with that idea too.
Absolutely.
Okay.
Questions from the audience. Where should we begin? Let's see. I'm looking for Megan with the microphone. Sorry.
If you guys can help us and just direct us a little bit.
There are actually two microphones, yeah.
Yes.
So if you can raise your hands and guide.
All right. What the hell?
Yeah.
Look, basically my question is, during your explanation, you didn't say anything about the fact that O3 is the main layer of the ozone layer. You talked about, ultraviolet rays, but the main source of ultraviolet ray absorption...
No, infrared.
Sorry, infrared. Sorry.
Yeah, that's totally different.
I get them a little confused.
Yes.
Sorry. Well, the O3, which is basically 3 atoms of oxygen, which I don't know what's the process, but after a XY period of time, the 3 atoms of oxygen usually come together to form the ozone layer, what we call the ozone layer.
Right.
Isn't there a way to nullify the amount of nullify the amount of CO2 we're emitting by also emitting an equal amount of O3?
Well, no.
There has to be a catalyst to produce O3.
It's exactly O3 it absorbs ultraviolet in the stratosphere, which is very important to protect us because ultraviolet is a high energy wave. Unlike infrared, which is not dangerous to our skin, ultraviolet can cause cancer. But at the lower levels, you get ozone being formed in cities, and that actually ozone is a 3-atom molecule, is also a greenhouse gas, and it's very toxic when it's breathed in to your lungs. It's very toxic. It's very bad. So these are 2 different problems that I think I want to separate for now, for the rest of the discussion, because the stratospheric ozone hole has to do with ultraviolet, not letting in more harmful, biologically breaking radiation. That's very different from the greenhouse effect I really want to focus us on, because so let's just keep those things separate now, but thank you for your interest in another important problem.
Another question? There's a question here, this gentleman standing.
Yes. You mentioned in one of your slides that there was a equilibrium in the ecosystem at the time of Industrial Revolution.
Right.
Since then, the carbon dioxide has been increasing in the atmosphere. And because of that, I imply that the ecosystem or the equilibrium is in imbalance. Now, is this going to be so? My first question is it still in equilibrium at the present state? And if not, then is it in a reversible position or irreversible position?
Right. Well, over long enough time periods were humans to stop emitting the fossil fuel carbon dioxide, the atmosphere would restore itself. It would start going into land, plants, and soils, and the ocean. Different timescales come into play. So in decades, it starts reducing itself, but it really takes hundreds of years to come down. And some of it's going to remain, the atmosphere is going to remain in a slightly elevated state for many thousands of years, which is why some people are starting to design engineered systems to maybe directly remove the carbon dioxide on an emergency basis if we really need to do that. This is setting up kind of football field size screens in the atmosphere, hundreds of thousands of them as the winds sweep through. It could be removed by various solutions, trying to form limestone bricks artificially. You know, there's some pretty wild schemes out there right now. But I think it's good to think about emergency measures. I definitely don't want to try to make people fearful that we're walking off the edge of a cliff in 10 years. I don't think that's the case, in my opinion. But this problem of changing the world's energy systems and industrial base is so huge. I also want to urge that we really need to be as urgent as possible. At the same time, we can't be too afraid, because the magnitude of the change is going to have to be so tremendous.
Mm-hmm. Tyler, can you say a little bit more about that? Because the book does help us to understand this question of the immediacy of the problem, right? The timeline according to which it makes sense to both think and to act. Mm-hmm. Can you talk a little bit about how that, how your perspective is consistent with, or a little bit different from, the politics of climate change and how the crisis mentality of climate change?
Yes, the climate has warmed maybe about 0.7 degrees C right now from the pre-industrial value. There is warming that's going to come even if we could magically hold the CO2 level constant, because the ocean is creating a drag. The ocean's taking longer to warm up, and so it keeps the Earth cooler than it would be even at today's CO2 level. So that's worrisome that even if we could hold the CO2 constant, it's still going to continue warming for about 20 or 30 years. So the Earth is behind. But the changes so far are, I'm going to say, relatively small. We see the shrinking of the Arctic sea ice, but they're not affecting massive climate zone changes or massive ecosystem changes or agriculture changes. That said, unlike the ozone problem that the nations could get together and change the chlorofluorocarbon, and it's relatively a small amount of the economy, we're talking about the world's economic and energy systems here. And so to change those over is to try to put in place, let's say we were to leave the fossil fuel industries as they are for 50 years, but bring in the new energies as renewables. That means in 50 years, and we're probably going to need double the energy in 50 years, we would need to bring in renewable energies or nuclear or non-CO2 emitting sources of energy, sequestering the carbon, bring them in at a scale equal to all of today's energy systems. And so that sort of boggles the mind. That's much more than setting up a couple wind turbines or putting a few photovoltaic panels here and there. This is putting in place non-CO2 emitting energy systems approximately equal to today's energy systems, and not even replacing today's, but allowing those to continue. And so the scale is really huge, and it's going to take those kinds of periods of time. So we have to all think, how are we going to personally stand, whether it's the plastic bags or whatever, but it's more than that. It's what policies are we going to support our governments to really try to make these changes.
Mm-hmm. Right, the scale of those energy systems and their implementation does take us back to questions of the most appropriate agents of change in this conversation, which turn out to be governments, municipalities, large-scale structures, right, that can put these things into place, which once again, right, brings up that tension between individual action and the collective, and in terms of energy efficiency.
Does anybody want to address that particular?
Yes. gentleman in the front here. Yeah.
And would it be appropriate for people, if you don't mind introducing yourself, we'd love to hear.
I'd appreciate it.
I forgot to mention that.
Good evening, and thank you for so far for a very informative conversation. My name's Deborah Stevens. I'm with Sheikh Khalifa Hospital, nurse manager. My question to you is, and you've just started to touch on it, was governments, for instance, I'm from England, are trying to look ahead and form, go for an alternative energy source, as most countries are looking to do in the West. How do you feel, or what is your opinion about clean nuclear energy? My understanding of clean nuclear energy is it will leave us with perhaps a very much larger problem than the CO2 problem, which is overwhelming us already. What is your opinion about clean nuclear energy?
Yeah, because nuclear, it works. We can build nuclear power plants, but I get very worried about the waste, about the nuclear waste. And so I say in the book, and I still stand by it, that I would be much more positive about nuclear if no one wanted to do anything bad with the waste. So that would mean if the world were totally peaceful, I would feel a lot better about supporting nuclear. There would be a problem with massive proliferation of nuclear, not just the waste, but even the supply of the uranium. The U-235 tends to be not that much. So we would have to go to breeder reactors, which would be even more dangerous in terms of proliferation of the materials into unwanted hands. And so let's see what happens first, world peace or changing the energy systems. Good question.
Yeah, thank you. There's a hand in the back, this gentleman in the back with the, yeah.
Hello, Professor. Thank you. And thank you.
And a name, please?
Ali Mohammed. I'm a consultant. So I just wanted to ask, you mentioned you showed us all the figures, and all the figures are very, very alarming and everything. But what's the counter? People still come up with counter arguments, and governments, and like some officials, companies, all of them, they come with a counter argument, even though all your figures show a clear rise in CO2 and
right.
And so. And who are these people who come up with a counter argument who are opposing our?
Well, some of them would be. It was well known in the United States that some of the oil companies were putting money into disseminating messages of confusion to the public. Oh, the science is still confused. So some of this is active, trying to suppress a realistic view of the situation. The climate itself there's uncertainty about the magnitude of the climate change, but there's no uncertainty about this carbon dioxide and the fact that it's a greenhouse gas. So one reason I wrote the book was to try to step back from climate and to explain the carbon system. Because I found through teaching people that once carbon is well understood, the concern tends to be much more well informed and much easier to get concerned without trying to weave in uncertainties about what's going to happen to clouds, and are the feedbacks with water vapor going to occur as they're being predicted. Some of the debates with climate are along those lines. They all agree it's going to warm, and actually the models are predicting that warming fairly well, and so it looks like it's going to eventually warm by 2 or 3 degrees C. And that may not sound like much, but the ice ages were only about 5 degrees colder as a global world. And the world was very much different from in the ice age. So this 2 or 3 degrees C warming can actually produce quite a bit different world with the way with where the climate zones are, eventual long-term sea level with the melting of the ice. But some people could say, gee, it's not tomorrow. It's not in 10 years. Al Gore is trying to scare people too much. We're going to be able to deal with it. I actually am an optimist that we are going to be able to deal with it, but it does need to be on on a very urgent agenda of concern, definitely not dismissed and say we can just wait a long time. And we have time, but it's got to be coupled with action now, which can't transform the world systems right now. That itself is going to take time. Mm-hmm. Does that answer your question well enough? And this is a big topic that...
Yeah. You know, there's an historian of science who recently visited our environmental studies program in New York, who's, if I'm not mistaken, about to publish, if not having already published, a book that answers very directly your question about the history of the dissemination of climatological knowledge related to CO2 in the atmosphere in the United States and how it has related to policy and administrative changes over time. Her name is Nancy Oreskes, and I don't know the title right now of her book, but she's someone who it's worth seeking out for a very detailed explanation of the process, at least of information dissemination and the extent of the conversation back and forth in the United States up to the present.
Yeah, it's interesting that political viewpoints then can start having opinions about the science.
Yeah.
I mean, sometimes people could even try to deny the CO2 coming from human activities because they'll say, well, volcanoes emit it. And so unless people understand the carbon cycle, one could hear that and say, gee, this person says there's no problem. So unless there's a groundwork of basic knowledge about the carbon cycle, it's easy to make people spin in one direction or the other, and to spin people into being even too fearful, as well as not fearful enough. So I'm one of my big things in the recent years is that everyone should understand the basis of the carbon cycle. At least to the extent that we understand our own hearts and lungs. If we go into a doctor, the doctor starts talking about your heart, you know something what that means. The doctor's not just talking to a blank wall. And I kind of think of the atmosphere, the soil, the plants as being like the organs of the big metabolic system that we have here. And if everybody just understood something about these interactions, at least the basic truths that are well established by science, the discourse would be at a lot better level because at least we have the facts down, and now let's start talking about what we can do about the situation.
Mm-hmm. Great. Let's take one from over on this side. The gentleman in the middle here with his hand up. Yeah.
Hello. My name is John Rogan. You mentioned that this is going to come down to a political decision in how the world solves this problem. From your perspective, what would be the ideal outcome of the Copenhagen conference next month?
Well, yeah. Ideally, I think the developed nations that have emitted most of the carbon dioxide really have to shoulder the bulk of the responsibility at this point. And they recognize that, but you often hear things such as, well, China is now the #1 emitter in the world as a nation, and therefore, if they don't sign something, the United States is not going to sign anything. I mean, you hear these things, and I think it has to be stronger. The responsibility has to be stronger. China is emitting large amounts as a nation, but the per capita is just now at the world average, and I think that the developed world really has to put the money in to show the new paradigm. China realizes that oil is not going to be pumped at 4 times its current value, which is what you would try to get if the whole world became like the United States. The oil would be pumped at 4 times its current amount. That's not even going to happen. That can't even happen. Whether it should or not, it cannot even happen. China recognizes this and is undergoing some large programs of wind turbines and photovoltaic cells. But I think at the Copenhagen, I would like to see the developed nations really shoulder the responsibility for a few decades.
Mm-hmm. And directly behind you, there was also a woman with her hand up. Yes.
Andrea Coney, just But what are your thoughts on carbon trading? I know this is something that companies tend to put forward as a counter to the emissions that are caused. Have you got any thoughts on carbon trading and the usefulness of such a program?
The environmental groups and the lawyers for analyzing the way that carbon trading worked for sulfur emissions for acid rain say that it will work. I thought, and many thought, that the carbon taxes would be a much simpler method, but the word is that would not happen. And so, but I don't know. I feel mixed about bills that are 400 pages long with all kinds of ways to game the system. I'm not an expert on it. I'm not following it. I'm more interested in the bigger picture. I don't know. I'm going to have to wait and see what happens on that. It's not going to matter too much in the short run, because even the laws that's currently being written in the U.S. and Europe are putting off the big reductions into decades from now. And so in some ways, I can say it's setting small precedents, but in other ways, laws could be changed and they don't have to make those large reductions in the future. I need to see us, I want to see us develop the energy systems that are almost going to take over in an evolutionary sense. I don't want to see huge complexity in these carbon accountings where every farmer's field now has to be analyzed for the carbon content of the soil. I see this as putting us into huge complications of accounting systems. And that could be very counterproductive in many ways too. But I don't have a strong opinion about whether the law should go or not. I don't know if Anne, if you want to say anything.
Well, I was going to. This reminds me, in some ways, related. Yeah, I know you were asked in an interview just yesterday about whether or not you offset, purchased offset credits for the carbon emitted for your flight over here, and I imagine I would probably have been rightly asked the same question had I been sitting in as well. Can you talk just a little bit about how you feel about that in a related sense to the question of carbon credit trading? What about offsetting, right? Is it something I can do that's a reasonable individual act to try to, I don't know, help raise awareness about climate change?
Yeah, I think the carbon offsets at least set a certain mental state that, oh, I need to offset I am emitting carbon, I need to offset it. But I don't think first of all, I know a lot about vegetation, and it's not even clear who's going to do the offsetting, how well I can trust that. If they're planting trees, will those trees be around in the coming decades? John and I were talking about this last night, and you're welcome to chime in on this too, because you felt the similar way, that almost the more science you know, the more reluctant you are to do carbon offsets, because you realize how tricky it is to guarantee that that's being offset. I mean, I had one of my NYU students give me a chocolate bar after the end of the semester. I hope that wasn't a bribe or something, but it was after grades were turned in, but the chocolate bar guaranteed that it was offsetting not the carbon in the chocolate, but the fossil fuel that went into making this. And it was very cute in a way, and I don't want to denigrate this. I'm very happy, but this kind of thing, it can't be the solution where every single item we have is going to have carbon calculations on it. I think we need to get the energy systems that are going to replace the fossil fuel energy systems, and then this accounting business will take care of itself.
Mm-hmm. Okay, another question.
Oh, okay, maybe in the back. I'd like to hear maybe from the, and then I'm sorry, Anne, I'm letting you do it.
No,
but then
it's fine.
The gentleman in the back.
Thank you. My name is Mohammed. I'm a student at Environment and Safety and Health at VIT Abu Dhabi. Actually, I have a lot of questions. Can I ask more than one question?
Yes.
Thank you very much. You mentioned that the carbon emissions are equal on all of Earth atmosphere. So why there is like China? They are having more than focus of carbon emissions. Why it's not like spreading all over the world, and there are any natural cycle making all the emissions, the carbon emissions, equal on the atmosphere? This is my first question.
So let me answer one at a time. So it's because the winds, the atmosphere is really one thing. The winds stir the atmosphere and mix it. Just like if you were put a little something into a glass of water, some salt, and you mix it, the salt spreads out equally. It spreads out equally because of the winds. There's really only one atmosphere. And it takes about a year to go from the northern hemisphere down to Antarctica. So there's a little bit of time, but it's only within 1 year, it's all mixed.
Okay, thank you. The other question is, you mentioned that in your diagram about the emissions of some organization, and you said that UAE is the most carbon emission, and due to UAE industrial history, it's younger than other organizations' industrial history. How can be this? What is the
that's a very good question, because some people are proposing that when we have to look at responsibility on the per capita basis, it's not just this year's emissions, but it's an integrated history of that country's emissions. So the UAE, that's only really been emitting for maybe 30 years or so.
But we didn't start making a lot of emissions since 30 years, maybe.
Right. So people, that's one approach to things like Copenhagen. So I didn't go into that, and this shows some of the controversy, whether it has to do with current emissions or a summed up history of emissions, in which case places like the United States, England, France, Germany have even more responsibility than if you just look at their emissions this year. So these are issues that are not yet well established, but I'm glad you brought that question up.
Thank you.
Thank you.
That's it.
There's a question here in the front. Lady in the front, yes, just on the
side, right by the camera?
Front side aisle.
Thank you very much for this very informative, important debate. My question is regarding the use of solar energy and how would it impact the reduction of carbon dioxide emission,
wonderfully so, because there's virtually no carbon emission from the solar energy collection. Some people would say, but it took oil or natural gas-derived electricity to manufacture the solar panels. So, however, that's in today's world. So what we could do, though, is take the electricity from the solar panel and make more use some of that to make more solar panels. Mm-hmm. And they have shown that the solar panels over their lifetime do make more energy than goes into their manufacture. So it would be possible to have a solarized world. It would be possible. But just in today's, you're going to have some factories using fossil fuels to make the solar panel, but because there's not enough solar energy to run the factories yet. But this could come. We need to start that, and so it becomes self-sustaining after a while. Does that answer your question?
Thank you.
Okay.
Here in the front.
Thank you. My name is Michael. I work for a renewable energy contractor, so I'm very much involved in this field. Just to let you know that coming to this lecture, I heard in the BBC that already it is not expected any binding agreement in Copenhagen. So this is the truth. This is where we are today. Mm-hmm. But what we can surely anticipate is that the price of the energy is going to go up a lot. It has. This is the only way. We don't know who is going to pay the party. The party will have to be paid, but probably we will have to get used to pay much more for energy. Mm-hmm. Do you share this view? Can we anticipate a life with a much higher cost of energy?
Definitely. The current, just take oil as the example, the current global consumption and production of oil is about 30 billion barrels a year, about 30 billion barrels a year. And the reserves are about 1 trillion barrels of sort of the easy oil. So if you divide 1 trillion, which is 1,000 billion by 30 billion, that's about 30 years of this trillion barrels. And now you can go to these more difficult sources. You can go to tar sands in Canada and start, but those are going to cost a lot more. And so oil is really, it's already back up to $70 a barrel from, it had been 50 for a while. It's already starting to creep up. I think oil is going to be the real major crisis. Some people are calling it a long emergency because it's not going to be like that. But once the production rate starts dropping even ever so slightly and the demand keeps going up, it's really going to cause huge price fluctuations. And how the oil crisis is solved, there are opportunities and challenges there. If it's solved by going to coal, then it's going to get much worse. But if we get smart at solving the oil crisis, we can solve the climate crisis at the same time. I think my personal opinion is that the oil crisis as a real crisis is going to hit sooner than the climate crisis as a real crisis. But yet we know the climate crisis is coming too. So we can use the oil problem as maybe a way to solve climate before it gets really, really bad. But I know the energy is going to get more expensive. And one viewpoint and I'm not an energy economist, but one viewpoint is that these higher energy prices are going to bring in the solar and the wind. And they're already doing that. They're going to bring them in, and so we're just going to see an evolutionary transition happen, and we may not have to do the tremendous accounting problems that the Copenhagen is going to engender. And so maybe, I'm sad to see that this is probably going to fail, but I understand why. Because the CO2 in Antarctica is going up at the same amount as the CO2 everywhere else, which means that the countries are going to be in this sort of terribly complex negotiations over just the issues, and now you see why these issues are complicated. Mm-hmm. Thanks for the question. Mm-hmm.
I think there were, several hands. I don't know how much time we have left. Time for one more? Two more? We'll try to take 2 more questions, please. Over on this side, there's the lady in the middle here. Yeah, you.
Hello, my name's Tamsin Carlisle, and I write about energy for the national newspaper here. I was a little concerned when you brought out the figures showing the high carbon footprint of the UAE and said you hadn't really considered the input into that, because it strikes me that a lot of the countries that get a really bad rap for high per capita emissions are those that are, in a sense, are doing the heavy lifting for the rest of the world. You know, the UAE, Saudi Arabia, Canada, where I used to live. They're all countries that extract raw materials and export them to the rest of the world. And that, in itself, is very energy intensive. And in Europe, on the other hand, well, it makes a lot of its GDP by turning these raw materials into higher value-added stuff with just a little extra energy input. So I just wanted to hear your opinion on that. Is this just an accounting problem that can be sorted out when we do get a lot of extra solar power up and running? Or is the world going to continue to need pretty much the same raw materials that these parts of the world are producing? And so is this going to be a persistent problem?
Wow. Well, if the gross world product needs to go up 4 times to bring the average standard of the world up to today's Europe or Japan or UAE or US, we're not going to try talking, plus or minus 10% here. We're talking kind of order of magnitude things, but 4 times, that's, if you just think about it, in the simplest way possible, that's going to sort of require 4 times everything, 4 times the computers being produced, 4 times the coal, natural gas, 4 times the highways, 4 times the plastics. Now I'm involved with some students right now in studying whether that is really going to need 4 times all those things, or which can we increase food production. But your question is really to the heart of it, and I don't think we want to start pointing fingers at something that's 7 times the world average versus 4 times the world average. Europe is probably a lot more efficient than the United States, partly because the distances are smaller, they use more trains, people tend to live in apartments, so the shared common walls, less heat and cooling costs, sort of a number of factors. And you brought up the UAE. Some of that's probably desalinating water because there's no water, more air conditioning, and some of the use of the energy to get the raw materials. So all these places are going to have roles to play, but the big question is, how do we get that growth? How do we get per capita up by about 4 times by 2050? How is that going to happen without significantly higher CO2 emissions? That's really the question that I am personally interested in. So some of these numbers are being brought about to stir up discussion. The numbers themselves are not trying to point fingers or put forth. Well, they can't be. The numbers show that they can't. Those numbers can't be solutions, though, right? I mean, would you agree with me that we probably can't have a world? We need a world with gross world product going up 4 times, but not CO2 emissions going up 4 times. Yeah. Okay.
Great. So I think there's time just for one more question, and there's a hand in the back on this side. Yeah.
Hello, I'm Alicia. I work at the Veti College where the students are represented here. And one of my students wants to know if there's any clever science into the extracting of CO2 from the Earth's atmosphere into some other form or some other process to extract it from the atmosphere, put it somewhere else, recycle it some other way.
Is the question... is there currently good science, or is there research that needs to be done? Is that the question? Is this a good place for science to start trying to look?
It was a curious question, and she's wondering too if it can get put into the earth. I think so, out of the air into the earth.
Yeah, it's actively researched. The U.S. government is putting quite a bit of money into that right now, called carbon capture and storage. CCS, carbon capture and storage. And so there's a couple different aspects. One aspect is how to capture it, and the other aspect, what do you do with it after you're captured it? Are you going to put it into a kind of a compressed liquid form and pump it down deep into waters, systems that will never be used for drinking water? Should it go into the ocean? Should you try to make it into bricks of some sort? It's quite an active area of research, but my judgment is it's also just beginning to be looked at, and I think some of the people that are interested in chemistry, there's really an active field here to try to figure out some new chemical pathways to put it into the most efficient forms, if that's a way to go. And I think it's definitely worth researching because we don't have an answer yet for the future, and we need to find some good models.
Yeah, back to the future problem, right? And the tremendous challenges that we face in looking forward for more efficient energy strategies. I believe we're out of time, but thank you so much for the questions that you've shared with us. And Tyler, thank you so much for helping us to grapple with them.
Thanks for being here, Ann, and I appreciate the questions. It's been a really good discussion, and hope it continues as we all have to think through these issues in the future.